In this tutorial, we will discuss how to combine exponential expressions, which involves applying a set of mathematical rules that describe how exponents behave. The following is a guide to the most basic rules and how they are used. To begin, an exponential expression is an expression of the form a raised to the power n. A is called the base, and n is called the exponent. The exponent indicates how many times the base is multiplied by itself. An example is when we write 8 as 2 times 2 times 2. Here, 2 is the base, and since it is multiplied by itself 3 times, we write 8 as 2 exponent 3. In what follows, we will discuss the basic rules for combining exponential expressions. First off, we have the product of powers rule. The rule for the product of two exponential expressions with the same base is given by a to the power m times a to the power n equals a to the power m plus n. Put simply, when multiplying two exponential expressions with the same base, you add the exponents. Here are some examples. Next, we have the quotient of powers rule. It states that a to the power m divided by a to the power n equals a to the power m minus n. In other words, when dividing two exponential expressions with the same base, you subtract the exponent of the denominator from the exponent of the numerator. Here are some examples. Moving on, we have the power of a power rule. It states that a to the power m all raised to the power n equals a raised to the power m times n. It means that when raising an exponential expression to another exponent, we multiply the exponents. Here are some examples. Next up, we have the power of a product rule. It is given by a times b all raised to the power n equals a to the power n times b to the power n. That is, when raising a product to an exponent, we distribute the exponent to each factor in the product. Here are some examples. Next, we have the power of a quotient rule, which reads a over b all raised to the power n equals a to the power n divided by b to the power n. In other words, when raising a quotient to an exponent, distribute the exponent to both the numerator and the denominator. Here are some examples. We also have the negative exponent rule. It states that a raised to the power of negative n equals 1 over a raised to the power of n. This rule allows us to convert a negative exponent to a positive one. Essentially, a negative exponent indicates the reciprocal of the base raised to the absolute value of the exponent. Here are some examples. Finally, we have the zero exponent rule. If a does not equal 0, then a raised to the power 0 is 1. That is, any non-zero number raised to the power 0 is equal to 1. Here are some examples. Now, on to our first test problem. Simplify this expression. The answer is 4 exponent 7. Next, simplify this expression. The answer is 10 exponent 5. And finally, simplify this expression. The answer is 3 exponent 8. I hope you enjoyed this tutorial. Please leave comments and suggestions for improvement, and don't forget to like and subscribe for more content.